anyone see anything about these graphs, comparing exponential graphs? Certainly, what you say? There is always going to be a common point of 0 and 1. And the reason that is just because we're exponent rules, anything to the power of 0 equals 1. All right? Here's the other thing. Will these graphs ever be negative?
Yeah.
No. Why? Right on. Like if you think, and I'm going to use this example here, I like to do this one with a piece of paper. If you're dividing by 2, right, what do I get to 0? No, there'll be like 2 electrons and I cut them in half or down to 1, right? But you see what I mean? Like mathematically, so if you're always dividing by 2, you're never going to get 0. So there will be an asymptote at y cannot equal 0 because a to the x will never equal 0, right? Like it's never, if you put like 8, like for example, if I say 2 to the negative 10, or 2 to the negative 100, or 2 to the negative 10,000, there'll always be a very, very small decimal that's left, okay? So you're never ever going to get 0. You can't get a negative because in order to get a negative number, you have to multiply or divide by a negative, but since we're only doing positive numbers, multiply again and again and again. I should mention these graphs are just going to be positive graphs, okay? Because the problem is when you end up with a negative base, you can't do like decimals. You can't do like negative 3 to the 2.5 is right. You can't do it. It doesn't work. Okay, so these are only going to be positive bases. Okay, but it's only because your calculator isn't powerful enough. Okay, right? All right. Finally, so what's the other point I'm going to put in here? Let's do domain first of all. I wish that Madison would be coming in the door right now because I would totally quiz her on this right now. What would the domain of all 3 of those graphs going to be? Okay, brave soul. This is the easy one. Luke, go. Yeah. Okay, you do range after. Do domain first. Yeah, good. It can in fact be anything, okay? That's what this arrow up here. And again, if we were to get x's 4 or 5, these numbers are going to get very, very big, very, very quickly. Okay, right? But it does actually go to be anything. As far as the range, oh, this is perfect. Just wait, Madison. In order to buy something off me, my class has decided to answer a math question.
I'm doing summer school.
No. Do you remember domain and range or not? What's the range of these graphs? Do you recall?
I don't know.
Okay, somebody help her. You can go get some food at the back. Drop some money. You can drop some money. You work here to buy things from me?
Oh, sure.
You can buy something on the back shelf.
Okay.
Okay, what's the range of this graph, please? Somebody help her. Yeah, go ahead, Owen. Yes. Yeah, I'm going to, y cannot be 0 is true, but I'm going to just say greater than 0. Okay, because that's technically, when you say that, that makes the assumption that you can go negative too, right? Which you can't, so we'll just say greater than 0. Are you actually buying something, or are you just sitting here just for my class? You're lucky I'm high on sugar right now. Okay, does that make sense so far what I'm saying on the board here for this?
Is it always the same?
Until we do transformations. Okay, because we're going to transform these. So my domain will always still be anything, but the y, depending on if the graph shifts up and down, can change. Okay, there's one last thing we're going to do. We're going to say when x equals 1, what does y equal for these graphs when x equals 1? You guys, please stay with me here. When x equals 1, what's y going to be? Okay, well, let's go back. Go ahead. Yeah, okay, so your base, okay? Which happens to be A. Okay, so if you look back at my chart over here, right, when x is 1, y is 2, because 2 to the x. When x is 1, y is 3, because of 3 to the x. When x is 1, y is 0.5, because 0.5 to the x. what we're going to do is we're going to use these three common points, which are like 0, 1, 1 in the base, and y can't be 0. And we're going to do transformations in graphic from there. Good. What time is it right now? Left to $5 bill took all my change. All right, we're good? Okay, let's do an example here to make sure we can do this. All right. Example 1, example 2. 2? Okay, please put a star and a heart beside this question. What that means is this will be on your next test and your assignment and your final exam, okay? On the final exam, there's about 7 graphs, okay? So every type of graph we do will be on it, so this is one of them, okay? If you want to pass your exam, make sure you can ace all the graphs. If you ace all the graphs, you're fine. Like, you're set for passing. You're not going to get an 80, you'll get a 50, okay, just for doing the graphs, all right? So here we go. If f of x equals 3 to the x, graph in state the domain of range y equals 2f of 0.5 x plus 1 minus 3. Okay, so first of all, do not be afraid when you do this. You guys can do this. The tricky part here is getting your starting points. Okay, excuse me. Then after that, you've done a million of these, right, where you make your different charts and go across here. The starting points for these graphs are more tricky than most of them. Okay, so I'm going to do what I normally do here on the left-hand side. I'm going to write f of x. I'm going to say f of x. And I'm going to write my 3 common points. When x, what are the 3 points that we learned from the last page there? What's the first point we're going to begin with? No? Okay, I'll help. I'm going to say 0, 1. Okay, the reason 0, 1, it always starts off, if I'm using 3 to the x, 3 to the power 0 equals 1, so it's guaranteed to be a point. All right, when x is equal to 1, what's y going to be here? Oh, goodness. Okay, guys, I need you to try here today, please. Yeah, go ahead. 3. Okay, how'd you get that? Just 3 to the power minus 3. Very good. Okay, so I need to make sure everyone gets that, because without this, it's impossible to do. So what you're saying here, using this original equation, x is 1, so 3 to the 1 is equal to 3. You can do more and more points. That's all I'm going to use here, though, from the graph. Is that? Did we do this? Yeah, from the last night, it was last year. But you guys also did this. What is y cannot equal 0? What can I call that? Well, that's my asymptote. Okay, so I'm going to use 2 points there and your asymptote, and that's going to be the graph. If you want to do 2, 9, 3, 27, go ahead, but that's enough to give you the shape of the graph. Austin, how you feeling? Good? Okay, now this is going to be just like last or earlier in the year. I'm going to start with 2f of x. Can I get someone other than Liam and Luke to be brave and tell me what 2f of x actually means, please? Alex, go ahead.
So you divide the y by 2.
Close.
So
Multiply the y by this. Right, because remember, outside the brackets is what it says, inside the brackets is opposite. Okay, so what this is going to change into is 0, 2, 1, 6, and y cannot equal 0. Okay? Because again, if you're dealing with an asymptote and I make it twice as big, well, it's still a line. Nothing's going to change there. Is this starting to come back for the left and right points for people, I hope, mostly? Okay, I'm going to get a second volunteer, please. 2f of 0.5x. Can someone be brave and tell me, please, what 0.5x means as far as the graph goes? And those 3 people are out, so I look here. Alana, go ahead. Yeah, divide x by 0.5. I like 0.5 because that's like times it by 2. Right? So that's going to change this to 0, 2, 2, 6, and y cannot equal 0. That stays as y cannot equal 0 because whether you stretch the line or compress it, it's still going to have the same value there. Are they okay so far on the transformations? Yes? Okay. Can I get a third volunteer? Bailey, it's going to be you. Can you tell me please what 2f of 0.5x plus 1 means? What does that x plus 1 mean? Yeah, good. Great. So just imagine that you're like solving for x here, right? Okay, so you'd have to do minus 1 to get rid of that. So what's going to happen is it's going to change to negative 1 comma 2, 1 comma 6, and y cannot equal 0. Now you're probably questioning yourself. I'll pick on you in a sec. Okay, you're probably thinking to yourself, well, y cannot equal 0. Why'd you even write it in there if it's going to be 0 all the way? There's that final last step. All right, question or answer? I got to go to Brad. Been aching to volunteer. Is that an answer or a question? No. Brad's been aching to volunteer the whole day. Brad, go ahead, please. Good. Okay. So 2f of 0.5 x plus 1 minus 3. Okay. So this turns into negative 1 and negative 1, 1 comma 3, and y cannot equal negative 3. Okay, so only on the last step is all that shifts the line, like the asymptote. That's the only thing that's affected by. Okay, because 0 times anything is still 0 as far as that, but adding or subtracting is going to do that. Jennifer, is this coming back at all? Yes? Okay. Any questions from everyone else in the class? Okay, once you do a few of these, this is really easy, but you got to do a few of them to get it down. All right. So I'm going to do graphs up here right now. Grab a piece of graph paper, please. Okay, I have to get from 3 to negative 3, so you can do the graph somewhere in the middle. All right, so these graphs aren't going to be real huge, even though they're exponential. All I have to get from my x values are from 1 to negative 1, so it's not going to be really big at all. My y's I have to get to 3. I'll go up a little bit just because I can. Okay, I'll give you a second to get that scribbled down or something similar on your page there. Okay, so we're going to begin by graphing this. What I'm going to do first, is I'm just going to plot the 2 points that I know. Okay, so the 2 points that I know in my graph are going to be negative 1 and negative 1, and then 1 and 3. Okay, those are going to be the points. And I'll give you a second to scribble here because this is a horribly important thing that I'm about to tell you. It involves a joke and everything that I've been using for the last 10 years. So I apologize to the asymptote. How do you draw an asymptote y cannot equal negative 3? Dotted line, okay? So I'm going to just put a little dotted line across like this. And that's going to say y cannot equal negative 3. Can someone remind me what an asymptote means again? What's an asymptote? Restriction, okay? So on a graph, it means that the line's going to come close to it but not actually hit it, right? So I'm going to show you how to graph this to make sure that it looks good here. The example I'm going to use is of, I don't know if you've actually gone to public skates. You know, like if you go, like if you put your skates on and family skate and all that stuff, okay? So I go to them all the time, and I have little kids, so I know what it's all about. So have you ever seen them when you have like a little 2-year-old and a 3-year-old in their little, what's it called, snowsuit, and they're like this and they can't move? Okay, and their mother or their father's like pushing them around and they're doing this and they don't really have any control of anything. Now my mother, who's a sweet lady, loves these moments, okay, because what she'll do is to little kids, she likes to skate with them. When it was a hockey player, she's met them later. She skates them around. Then when she gets around 3 or 4 corners, what does she do? Let's go like this, right? Which is then the kid screams and all chaos happens. So this graph is going to be like that kid that just got let go from my mother, okay? So what's going to happen is, what is the kid trying to do here? Trying to stop, okay? So the boards are going to be the asymptote. This person can't, the kid can't actually hit the So now when the kid comes close to the boards, assuming he or she doesn't fall, okay, what's their motion going to be? Are they going to like bounce off like this? Maybe. Okay, probably not though. What they're sort of hoping they're going to do is like hang on for dear life like this as they're going along to, okay? They are not a figure skater. They're not a hockey player. They can't like do loop-to-loops and like do a power turn and say, take that down, Sadler, and spin her afterwards, okay, right? It has to be like that. So the point I'm trying to make with that is, what's going to happen? These two lines, you're just going to connect them, and the line tends to want to go in the same direction, which you can't do. But I'm going to come down to the asymptote, and I'm just going to slide right along the asymptote.
Do you like a straight line in the curve?
Sort of like that, okay? It's almost like that, okay? If you want to make it like a U, that's fine, but the point is, this continues right along this line. Like, it doesn't turn into a U shape or a parabola or anything like that. Okay, right? Like, it continues along. And then this is going to come up, okay? Now, there's a slight curve there, okay? But that's enough for me. What I don't want to see is a U. I want no one in the class. And again, if you take a look back to our warm-up here today, or our warm-up, sorry, going back to this, notice none of these were U's, right? They all sort of slid along the same way. And the pattern for all of these is going to be the same thing.
Is that your square root graph?
Yeah, it's like the opposite of a square root graph, in fact.
Oh, like,
Right? Yeah.
doesn't touch it.
Yeah, exactly. Okay, so before we finish this one, can I get a brave soul to tell me the domain and range of this graph? Okay, Liam, we'll start with you. Liam, what's the domain and range of this graph, please?
Anything?
Good
No.
for X?
Oh,
Yeah.
Range
Range going to be
is always greater than y.
greater than what, sorry?
Y. Or no, not greater than y, but greater than -3.
Yeah.
Sorry.
Okay, now one thing to remember, there will be someone in this class, let's call them Liam, okay, that is going to give me for an answer on their test, y is greater than or equal to -3. Can somebody please tell me why that's incorrect, other than Liam? Why is greater than or equal to? Yeah, go ahead. You can't touch the line, it's got to be greater than, okay? So someone will do greater than or equal to here, but it's got to be above. Okay, there's one more example for you guys, and I'm going to stop for today. It'll be a graph just like this, different numbers, so I want you guys to try it out, okay? Here we go, example 3, Brad? 3. Says, I should probably call that after that or something like that. All right, I'm going to give you guys a chance to do this for yourselves. If you need help getting your first 3 points, look at the last example, you can do it. Okay, this means you too, Liam. Okay, try this one out, please. All right, I'm going to hit pause. I got to make one quick phone call.